Okay, I'm going to go over the organic chemistry naming packet. Some things that you will need as I go over it. On the website, I have this tips and suggestion sheet. So I'll be reading off of this some on and off, so you might want to grab that. And you also might want to grab your foldable that we made earlier in the week to reference back and forth with. So I'm not going to keep pulling them up and down during the video because that gets distracting. So I will reference both of those and tell you when I'm getting information off of them. All right. So on the foldable, on the very back side, we have all of our prefixes and suffixes. The prefixes, all those numbers, represent how many carbons that we have in a chain. And all of the suffixes tell us what type of bonds we have, if we have single bonds, double bonds, triple bonds. And then we also have one that says branches, always end in YL. Anytime we have something that's some type of shape or ring structure, we put the prefix of cyclo on it. So that kind of covers the majority of them. The front side of our foldable and the inside of it is all about functional groups. And we don't get to functional groups until, I think it's number 6. Yeah, so we won't use the front and the inside of the foldable until we get to 6A. So if you need any of the prefixes or suffixes that I'm talking about now, go to the back of your foldable. On the tip sheet, I have some just very basic steps on how to name an organic compound. And once you can figure out how to name it, it's really easy to draw the structures. So the first thing you have to do is find the longest continuous chain of carbon and draw a line through it. The carbon chain must be connected together. The chain can twist and turn multiple times. So if you look at number 1A in your packet, we can go through and we can count how many carbon are connected together at once. So if we count, we can start counting here and go down, and that gives us 5 carbon. Well, that's not the longest chain. It says on our tip sheet that the chain can twist and turn. So if we start here at the top and we go down like this, it actually gives us 6 carbon in a row. Another way that we can do it, and there's multiple ways to make chains of carbon here. We can start at the bottom and go up, or there's one last way. We can start at the left and go down. And all 3 of those ways have 6 carbon. So it doesn't matter which one you choose, you're going to come out with the same answer each time. So I'm just going to stick with this one. So I found my longest chain of carbon. There's 6 of them in a row. Step 2, circle anything attached to the chain. These are called branches. Carbon branches end in the suffix YL. So this would be a branch, and this is a branch. So we've got 2 branches on our little carbon chain here. Number the carbon in the chain from one end to the other. Make sure the branches have the lowest number combination. Okay, so for this one, I can either start numbering here, or I can start numbering down here. I want my branches to be located on the lowest number carbon. So if I start numbering from the bottom, this methyl group would be on the 3rd carbon, and this ethyl group would be on the 4th carbon. If I start numbering from the right, my ethyl group would be on the 3rd. My other branch would be on the 4th. So on this one, it doesn't matter which way you start from. You'll get a correct answer for both of them. I'm going to start numbering from the bottom. Right? Number 4, when writing the name, list the branches first alphabetically. All right, so now we have to figure out what to name our branches. We know that they end in YL, but what is their prefix? So if we look at the branch on the right, CH3, there's only 1 carbon. So the prefix for 1 is meth. And since it's a branch, the suffix is YL. So that CH3 we call methyl. If we look at our other branch, it's CH3CH2. It has 2 carbons in it. So the prefix for 2 is F, ETH, and the suffix is YL. So that one is ethyl. All right, number 5, write which number carbon the branch is attached to. Use dashes in between numbers and letters and commas in between numbers. So I have to list them alphabetically. So I'll list ethyl before methyl. And if this bottom carbon is carbon 1, then we have carbon 2, carbon 3, carbon 4, carbon 5, carbon 6. So ethyl is on carbon 4. So I'm going to call this 4-ethyl. You have to get the punctuation correct. So dashes in between numbers and letters, commas in between numbers. And now my methyl group is on the 3rd carbon. So I'm going to put dash 3 dash methyl. And then number 6, after all the branches are numbered, named, listed alphabetically, write the name of the chain. So going back to our parent chain, it has 6 carbon in it. The prefix for 6 is hex. They have all single bonds between them, and I know that because there's only single dashes. And so if it's single bonds, the suffix is ane. So then we would write it as hexane, H-E-X-A-N-E. So this methyl hexane is all one word. So that's our final answer right here. This 4-ethyl-3-methyl hexane is the answer for A. All right, let's do B. The first thing you have to do is find the longest chain. If we went straight across from left to right, that would only give us 4. If we start at the left and turn and go up, that would give us 5. So that is the longest chain of carbon. And then we end up having 2 branches. All right, so we need to kind of name these branches. The one on the bottom, it only contains 1 carbon, so the prefix for 1 is meth, and it's a branch, so it ends in YL. Same thing with our other branch. It only has 1 carbon, so it's also called methyl. So instead of writing this twice, we can just call it dimethyl. We have to tell where these methyl branches are located. We want the lowest numbers possible. If I start numbering at the top, and that carbon's 1, that would give me a methyl branch on carbon 3 and a methyl branch on carbon 4. If I start numbering from the left, start numbering here, that would give me carbon 1 and a branch on carbon 2 and carbon 3. So 2, 3 is a lower number combination than 3, 4. So I'm going to start numbering from the left. So my branches are on 2, 3. We use commas in between numbers, dashes in between numbers and letters, dimethyl, and now we need to name the chain. There are 1, 2, 3, 4, 5 carbon in a row. The prefix for 5 is pence. It's all single bonds.
May I have your attention, please? Maintenance is going to be working on the.
Okay, sorry. So our chain is 5 carbon long. The prefix for 5 is pence. Single bond, so it ends in ane, so that gives us pentane. So our final answer for B is 2, 3 dash dimethylpentane. All right, letter C. Find the longest continuous chain. It looks like it's going to be 4. So we can just go straight down. Anything that's not part of the chain is a branch, so we'll circle those. We have 2 branches. The branch on the left only contains 1 carbon. The prefix for 1 is meth. Branches end in YL. Same thing over here. It's only 1 carbon. So our prefix is meth, suffix is YL. So again, we have 2 methyls, so that would become dimethyl. We have to decide what number carbon they're attached to. If we start numbering from the top, they're both attached to carbon number 2. If we start numbering from the bottom, they would both be attached to carbon number 3. So we need to number from top to bottom. We have to tell the location of both the methyl groups. So they're both on carbon number 2, and we have to list it 2 times. So it's 2, comma, 2, dash, dimethyl. Looking at our parent chain, there are 4 carbon in the row. Prefix for 4 is bute. So single bonds, A-N-E, butane. So our answer here is 2,2-dimethylbutane. Letter D. We have to find the longest continuous chain of carbon. On this one, there are multiple ways that you can get a long chain, and you just choose which one you prefer, but you should get 6 carbon in a row. I'm going to do this way. So that gives me 6 carbon. Then we have a branch here and a branch here. Alright, so we need to name our branches. The top one, CH3, that's only 1 carbon. The prefix for 1 is meth. Branches end in YL, so that's methyl. The branch on the bottom is CH2CH3. So we have 2 carbon. The prefix for 2 is F. Branches end in YL, so we have ethyl. And we have to tell which carbon they're located on. Just by looking at the structure, we can see that both the branches are located closer to the left side of the chain than the right-hand side. So that's more than likely going to give us our lowest number combination. So if we count from left to right, both branches are located on carbon number 3. So now we list our branches in alphabetical order when we write the name. So ethyl comes before methyl. Ethyl's located on carbon 3, so it's 3-ethyl dash 3-methyl. And then name the chain. There are 6 carbon in the chain. Prefix for 6 is hex. It's all single bonds, so it becomes hexane. Okay, on number 1, you work E through H the exact same way. I'm going to move on to column number 2. Number 2, exact same thing going on. The only difference, these are condensed structural formulas, so they didn't put the dashes in between each CH3. They took all those dashes out, but it still represents the same thing. So on letter A, you find your longest continuous chain of carbon, and remember our chains can twist and turn, so we can really do this. So everything is in the chain. There are no branches. So real easy, we just count our number of carbon, and we have 5. The prefix for 5 is pent. Suffix, single bonds. So this is just pentane. Right, on letter B, find your longest continuous chain of carbon. It looks like it's just going to be 4 carbon, so I always pick the simplest one. There's my 4. We have 1 branch. Our 1 branch contains only 1 carbon, so its prefix is meth. Suffix is YL, so we call that branch methyl. And then we have to tell which carbon it's located on the chain. It's closer to the left side of the chain, so that's the end I'm going to number from. So the methyl branch is on the 2nd carbon. So I'm going to say 2-methyl. There's 4 carbon in the chain, and that prefix is bute. It's single bond, so it ends in ANE. So 2-methylbutane is 2B. Letter C. We have to find the longest continuous chain again. Yeah, it just looks like that straight chain is the longest one. And then we have 2 branches. Both our branches only contain 1 carbon, so they would both be called methyl. If we have 2 methyl groups, they would be dimethyl. So now we have to tell where they're located. It looks like it doesn't matter which end we count from. They're both on the 2nd and the 3rd carbon. So we're going to put 2, 3 dash dimethyl. Again, it's a chain of 4 carbons, so the prefix is but. Suffix is ane. So 2,3 dimethyl butane. Right, and then you will do D through H the same way on number 2. Alright, so going on to number 3. 3, A, B, C, F, and G. Same thing you've been doing. So find the longest chain, circle your branches, name your branches, number your branches, write the name of the parent chain. On H and I, we're going to do the opposite. They've given us the name, now we need to draw it out. I think these are a lot easier. So with 3H, tells us 3-methylhexane. Now we have to work backwards. Instead of starting with branches, we start with the chain. So hexane. Hex tells me 6 carbon. So 1, 2, 3, 4, 5, 6. A and E tells me single bonds. And then 3-methyl. So that means on the 3rd carbon, I have CH3. Or we can say on the 3rd carbon, we have meth, which represents 1. So we draw a C. So that's the main part of it. We know back from when we learned how to draw Lewis structures that carbon has to bond 4 times. Well, if you'll notice, none of our carbons have 4 bonds on them. So we have to fill all the remaining bonds in with hydrogen. So starting on the carbon on the left-hand side, it's only bonded once. So I have to fill it in with 3 hydrogen. The 2nd carbon, it's been bonded twice, once on the left, once on the right. So we need a hydrogen on top, hydrogen on bottom. The 3rd carbon has been bonded 3 times, so it only needs 1 hydrogen. Our methyl branch down at the bottom, it's only bonded once, so it needs 3 hydrogen. The 4th carbon's bonded twice, so it needs 2 more. The 5th carbon's bonded twice, so it needs 2 more. And then the 6th carbon's bonded once, so it needs 3 hydrogen. So that is now 3-methylhexane. Letter I, 3-ethylpentane. So we have to draw the chain first. So our chain tells us pent. That's 5 carbon in a row. A and E tells us all single bonds. And then it says 3-ethyl. So on the 3rd carbon, I need to attach 2 more carbon. Alright, now I have to go through and fill in my hydrogen. Each carbon has to have 4 bonds. The 1st carbon on the left only has 1, so it needs 3 more hydrogen. The 2nd carbon only has 2 bonds, so it needs 2 hydrogen. The 3rd carbon has 3 bonds, it only needs 1. The 4th carbon has 2 bonds, so it needs 2 more. And the last carbon has 1 bond, it needs 3 more hydrogen. Now our branches. That middle carbon has 2 bonds, so it needs 2 more, 1 on the left, 1 on the right. And then our bottom carbon, it only has 1 bond, so it needs 3 more. Alright, so this is now, where'd it go? our 3-ethyl pentane. Everything in green is part of our 3-ethyl pentane. So these are called structural formulas. We can also do a condensed version. So I'm going to clear this out and I'm going to do them again. And I'm going to write them condensed. Alright, so for 3-methylhexane, I still start out the same way. I need 6 carbon in a row. Oh, how about 6 instead of 5? Alright, and then 3-methyl. Well, I know that methyl is only 1 carbon, and it's going to attach itself 1 time to the chain, so that's only 1 bond. So it has to have 3 hydrogens. So methyl is always going to be CH3. There's a chart in your book that shows you all these branches, and you can memorize it if you want, or you can write it in your notes if you want. Methyl is always CH3. Ethyl is always CH2, CH3. Propyl is CH2, CH2, CH3. Every time you add another prefix, you're adding another CH2. So for 3H, 3-methyl, for my 3rd carbon, I'm going to put a CH3. And you can put your CH3 on the top. It doesn't matter which side it's on. Alright, so now I have to fill in my hydrogen, and so this is where it becomes condensed. So the 1st carbon needs 3 hydrogens, so I'm going to turn that into an H. My bonds turn into hydrogens. And it's not very neat looking on the smartboard. It works much better in pencil. But you get the idea. Alright, so now I'm going to do it again with pentane. So I need 5 carbon in a row. And then on the 3rd carbon, I need an ethyl branch. So on the 3rd carbon, I'm going to put CH2, CH3. And now I'm going to go back to my chain and fill in my hydrogens. So I need an H3, an H2, an H, and an H2, and an H3. It doesn't matter to me which way you do these. If you do them structurally or condensed, you'll get the same answer, and I can read both of them. So either one will work just fine. Alright, so that's enough on 3. Let's look at 4. 4A, this is the first time we use a double bond. One thing with double bonds, not only does the suffix change, but you also have to tell where the double bond's located. Again, we use the lowest number carbon possible. So on 4A, we have a chain of 4 carbon, so that's bute. It has a double bond, so it ends in E, so that's butene. But we have to tell which number it's located on. Well, it's in between carbon 2 and carbon 3. We have to use the lowest number possible. So for 4A, it's going to be 2-butene. And it doesn't matter which way we count from, it would still be 2-butene. 4B, in your book it talks about aromatic compounds, aromatic structures. 4B is one of them, and it's called benzene. When you have a hexagon with a circle in it, it means that there is a double bond on every other side. I want to draw my lovely hexagon here. So we have a double bond here, a double bond here, and a double bond here. So that's how you draw benzene, or you can do it the shortcut version, where you just draw a hexagon and put a circle in it. So for this particular problem, we treat benzene like it's the parent chain, and we will treat these 2 CH3s as branches. So we know CH3 by now, we've done enough of them. CH3 is methyl. And we have 2 of them, so that's dimethyl. We've got that. Where are the methyls located? Well, one thing about ring structures, they twist and move around all the time. So carbon 1 is wherever you want it to be. And since our branches have to have the lowest number combination, we want our branches as close to carbon 1 as possible. So for this example, we're going to say they're on carbon 1 and 2. So 1, 2 dash dimethyl, that's our branch. And now name the chain. Benzene. That's all supposed to be one word. And it won't let me move it. So 1, 2 dash dimethylbenzene. All one word. There should not be a space in between methyl and benzene. All right, letter C. It does not have a circle in it, so it is not benzene. So if you look at the back of your foldable, it tells you what to do with the shape. It has the prefix of cyclo. So to determine how many carbons we have in a shape, we count the number of points. So this has 6 points, obviously, because it's a hexagon. So they're all single bonds. We don't have any double dashes in there. We have to put the prefix cyclo. It has 6 bonds, so that's hex. They're all single, so cyclohexane. 4D is kind of tricky. We have a benzene, but now instead of treating benzene as the parent chain, we treat benzene as a branch. The CCH, because it has a triple bond in it, that's our parent chain. This is our branch. So double bonds and triple bonds take precedence over branches. So the CCH is our parent chain. Benzene is our branch. When benzene is a branch, it's now called phenyl. And this is how we can tell the difference in a name when we have to draw it out of which one's the branch and which one's part of the main chain. So if benzene's a branch, it's called phenyl, and we can remember that because it ends in YL. All right, so phenyl is our branch. We have to name our chain. Our chain has 2 carbon in it. The prefix for 2 is F. It has a triple bond, so that suffix is YNE. The triple bond is located in between carbon 1 and carbon 2. So that should be 1 ethyne. And then our phenyl is our branch, so we'll list it first. It's located also on carbon 1. So we have 1 dash phenyl dash 1 dash ethyne. All right, letter E, another shape, no branches. Count your points. You have 4 of them, so that's 4 carbon. Bute is the prefix for 4. All single bonds, so our suffix is ANE. Instead of a chain, it is a shape, so we have to use cyclo. Cyclobutane. All right, letter F, we just have a straight chain of 3 carbon. We have a triple bond. We have to tell where the triple bond's located. The triple bond's located closest to the left side rather than the right side. So that means the triple bond's located in between carbons 1 and 2. We have to use the lowest number combination. So the triple bond's at 1. Their prefix for 3 carbons is prop. Suffix for a triple bond is YNE. So that one is 1-propyne. All right, let's look at 5. You know what, I'm going to stop right here because this video is getting kind of long, and I'll start up with number 5 in the next video.